For x greater than or equal to 0, the tanh function, tanh of x, is super-multiplicative. And so this means that if we have alpha and beta that are non-negative, then tanh of alpha times beta is greater than or equal to tanh of alpha times tanh of beta. So for every non-negative alpha and beta, tanh of the product is greater than or equal to tanh of alpha times tanh of beta. The tanh function is e to the x minus e to the minus x over e to the x plus e to the minus x. The first derivative, so we'll differentiate the numerator. So this will be e to the x plus e to the minus x times the denominator. So we square here, minus, then we have the numerator, and the derivative of the denominator will be exactly like this. So we square, and then we divide by the square of the denominator. And as we can see here, the first derivative is positive. Now, this means that the tanh function is strictly increasing. Note that tanh of 0, so we'll have here in the numerator 1 minus 1 when x is equal to 0, so that's 0. And so tanh will strictly increase from 0, and then limit x tends to infinity of tanh x. At very large values of x, those exponentials will dominate, and so the tanh will approach unity. So over the non-negative real line, basically the tanh function will increase monotonically from 0, and it will approach unity as x tends to infinity. Because the tanh is increasing, then let's consider, this case in which we want to show this inequality. So let's assume that either alpha or beta is greater than or equal to 1. So let's take beta greater than or equal to 1. If beta is greater than or equal to 1, then alpha beta is greater than or equal to alpha. Now, because the tanh is strictly increasing, then if we apply tanh to both sides of this inequality, then tanh of alpha beta is greater than or equal to tanh of alpha. Now, this is greater than or equal to tanh of alpha multiplied by a number, by here, if we put here a positive number that is less than or equal to 1. And, well, we can choose tanh of beta, because this tanh function, again, the tanh is going from 0 approaching 1. So tanh of beta is greater than, is less than or equal to 1. So tanh of alpha will be greater than or equal to tanh of alpha times tanh of beta. And so if beta is greater than or equal to 1, we have established the inequality that tanh of the product, tanh of alpha times beta, is superior to the product of tanh of alpha and tanh of beta. It won't matter if we take alpha to be greater than or equal to 1. If either alpha or beta, if one of them is 0, then we have basically both sides of this inequality will be 0, and it's okay. So now the case that we need to focus on is when both guys are living between 0 and 1. So this is now the case of interest. Claim tanh of x x greater than or equal to 0 is a concave function. And to check concavity, we can basically check the second derivative. We have the first derivative, and the first derivative, if we simplify it, we have this term here in the numerator is exactly what we have in the denominator. So that's 1 minus, then this e to the x minus e to the minus x squared over the denominator here. This is exactly the square of the tangent. So that's the first derivative, 1 minus tangent squared x. Now, what is the second derivative? So the derivative of 1 is 0. And then we have minus tangent squared. So let's apply the chain rule. So we'll have minus 2 tangent of x. And then the derivative is, of tangent itself is 1 minus tangent squared of x. Now, tangent is between 0 and 1 when x, and so this is non-negative, and this is non-negative, and then we have minus 2. So basically what we have here is a negative second derivative. So the second derivative is negative, indicating that, okay, so in fact, the second derivative is strictly negative if x is strictly greater than 0. And so the tangent function is concave. What does this mean? Suppose that we have a concave function. The main definition of concavity is that, so is concave. So this will imply that if we take lambda between 0 and 1, then h of lambda x plus 1 minus lambda y, if the function is concave, this is greater than or equal to lambda h of x plus 1 minus lambda h of y. Now, our tangent function is concave, and we are interested in the case in which alpha is between 0 and 1 and beta is between 0 and 1. So we can choose alpha to play the role of lambda here. So tangent of alpha beta plus 1 minus alpha, and then for y here I will put 0. So tangent of alpha beta plus 1 minus alpha times 0. This is from concavity greater than or equal to alpha tangent beta plus 1 minus alpha tangent of 0. So tangent of 0 is 0. Okay, and so based on the concavity, we have tangent of alpha beta is greater than or equal to alpha tangent of beta. This is very close to the inequality we are after. The inequality requires, for the tangent to be super-multiplicative, tangent of alpha beta must be greater than or equal to the product, tangent of alpha times tangent of beta. But here we have alpha. So if we can show that alpha is greater than or equal to tangent of alpha, and we already have the term tangent of beta here, then we are done. So the question now is, can we say that this is, so tangent of beta, copy paste, but then can we say that alpha is greater than or equal to tangent of alpha? If we show this, then we are done. So let's define a function. I define a function g of x, which is x minus tangent of x. Now g of 0 is equal to 0 minus tangent of 0, which is 0, so that's 0. Now, what is the first derivative? First derivative of x with respect to x, that's 1. Tangent, we know it from before, it is 1 minus tangent squared of x. Now, so this is tangent squared of x. And so this is strictly positive if x is strictly positive, which means that this function g of x is strictly increasing. So it starts from 0. So it means that g of x is indeed greater than or equal to 0 when x is greater than or equal to 0, because it's strictly increasing and it starts from 0. So that's it. This is exactly what we need. Then x is greater than or equal to tanh x. So again, we used concavity to show that tanh of alpha times beta is greater than or equal to alpha tanh of beta. And now we have alpha greater than tanh of alpha. And so we have our result here. And so indeed, the tanh function is super multiplicative with x greater than or equal to 0.